Hello, and welcome to Linear Equations. This is a college algebra take on it, so a bit of a step above intermediate algebra, but definitely something that is open for everyone. Let's start with the definition. An equation is a statement that two mathematical expressions are equal. An equation consists of something on the left, always an equal sign, and then something on the right. Always. There's three parts to an equation. Specifically, by definition, a linear equation in one variable is an equation that can be written in the form ax plus b equals 0, where a and b are constants with a not equal to 0. If a were equal to 0, then it would just be a constant, and b would have to be 0 as well. So in order to have a variable there, a cannot be 0. Now, when we're working with equations, there are two properties of equality that we use, but it really takes care of all four operations. The addition property of equality: if a, b, and c are real numbers, then a equals b is equivalent to a plus c equals b plus c. So if we add the same thing to both sides of an equation, the equation remains balanced. It remains true. This holds if c is a negative number, and that takes care of our division as well. So the multiplication property of equality: if a, b, and c are real numbers with c not equal to 0, then a equals b is equivalent to ac equals bc. So we could multiply a non-zero number on both sides of an equation and it remains true. All right, so this gives us our basic steps, and we'll generally use, I forgot to get my pens ready because that's what happens all the time. What this comes down to is our order of operations. Sorry, I just totally forgot what I was going to say. So we can add and subtract from both sides of an equation. In order to solve, we peel away this way. In order to simplify, the order of operations tells us to go top down. But as we're going to be simplifying here, we kind of use parentheses, and then we'll do some addition subtraction, so it's not completely the same, but it's pretty close. So we'll take this 2, multiply it by the 1, and we'll multiply the 2 by the negative 3x to get 2 minus 6x plus 1 equals 3x. Now, definitely, we want to combine like terms on each side of the equation. So on the left side, a 2 and a 1 make 3. We'll have 3 minus 6x equals 3x. So we'll simplify, we'll combine like terms on each side individually. Now we're going to treat this as an equation. Now we're going to use the addition and multiplication properties. Let's add 6x to both sides. If 3 equals 9x, bringing it over here, 3 divided by 9 equals x. And we will always simplify our fractions to get 1/3. All right, fantastic. All right, so we could add something to both sides of an equation. We could divide something to both sides of an equation, and all remains good as long as we're not dividing by 0. Now, in a problem like number 2, 2/7 n plus 2 equals 4/7. In general, we don't want to have to deal with those sevenths. So we're going to multiply everything, every single term, by 7. And there are 3 terms. They're separated by plus signs, minus signs if there were any, and equal. So we will have 2/7 times 7 is 2n, right? 2/7 n times 7 is 2n. 2 times 7 is 14. And 4/7 times 7 will give us 4. Once we do that first simplification step, whether it is distribute or eliminate denominators, now we get into the addition and multiplication principles, and we could subtract 14 from both sides. If 2n equals negative 10, then n equals negative 5. And we could always check this by substituting. We could use our calculator as an assistant if we needed to. Last one of this type. Now, it's a little bit of everything. So the first thing I notice is fractions, and fractions bother me way more than any parentheses would. So I'm looking at 2, 3, and 4, and in order to find the least common denominator, I'm going to take 4, and it's the largest number, so I'm going to list the multiples of 4. And I notice here at 12 It's an even number, so 2 goes into it, and it's a multiple of 3. So my LCD will be 12. So when you're dealing with just integer values in your denominators, take the largest one, list the multiples, and find whatever they all go into. So now I'm going to multiply 12 times this whole fraction. I'm going to multiply 12 by this whole fraction. I'll multiply 12 by the 5/4, and I'll multiply 12 times this whole product, 2 times 1 minus x. All right, those are all 12s. There we go. So 3 goes into 12 4 times. So I'll have 4 times x minus 5 plus sign. 2 goes into 12 6 times. So that 6 will be multiplied by 3 minus 2x equal sign. 4 goes into 12 3 times. And that's why I put the parentheses on this one on number 3, which I didn't do on number 2, because I knew there would be some multiplications going on afterwards. There is no denominator here, so I'm going to take 12 multiplied by 2. Don't forget to use the sign negative, subtraction. 12 times 2 is 24 times 1 minus x. So that's taking care of denominators. Now we'll take care of distribution signs. So the parentheses are telling us 4 times x, 4 times negative 5, 6 times 3, 6 times a negative 2x, equal sign, 3 times 5 is 15, minus 24 plus 24x. Now on each side I'm going to combine like terms. On the right side I have some numbers that combine. On the left side I have some numbers that combine and some variable terms. So the 4x minus 12x is negative 8x. A negative 20 and a positive 18 is a minus 2. Equal sign. 15 minus 24 is negative 9 and plus 24x. All right, to solve this, let's add 9 to both sides. Normally I take all my variable terms to the left. I didn't do that in this instance. Let's add 8x at this step as well. And I think probably the reason I didn't take my x's to the left is because it was a negative over there, and I don't like to deal with negatives. I try to be a positive person in general. So if I could take it and make positive variables on the right side, I'll do it, because I prefer to be positive rather than have to deal with dividing by negatives. Now, I'll be honest, this seems like a weird answer, so I'm going to use my calculator over here. I'm going to do this. I'm going to do 7 divided by 32, and I'm going to store it for x. And click enter. So this number, 7/32, is stored for x. So now I'm going to type in x minus 5 with parentheses, because that's the whole numerator, plus 3. Add to that 3 minus 2x. That's not a minus sign. 3 minus 2x, close parentheses, divided by 2. And find that answer, negative 0.3125. Now I'm going to evaluate the right-hand side. 5/4 minus 2 times 1 minus x. And we see that the left-hand side and the right-hand side evaluate to be the same value when x is 7/32, and that's how we know that we're right. So when I get a messed up answer, like an answer I'm thinking, no, it can't be, I check it with my calculator, make sure. I can always just evaluate in order to see what we have going on here. All right. Get my cursor a little closer to where we are. It's going to help us here in a minute. All right, the U.S. per capita income can be modeled by f of x equals 1,550 times the quantity in parentheses x minus 2,011 plus 50,000, where x is the year. Determine the year when per capita income might be 62,400. This tells us right here, determine the year. That's the word problem's fancy way of saying solve for x, because x is the year. Solve for x. So that tells me I'll leave the x alone, and it's the y part, the f of x, that is 62,400. Also because the income is modeled by f of x, and this is an income. So I write down the problem where I have 62,400 equals 1,550 times x minus 2,000, add 50,000. So 62,400 equals, I like to distribute first. I don't happen to know what 1,550 times 2011 is in my head, but I'm going to find out. 3 million minus 3,117,050 plus 50,000. So I want to combine my like terms over on this right hand side of the equation. So if my answer is negative, so that negative 3 million, let me do that correctly, negative 3,117,050, add to that 50,000, and that is negative 3,067,050. Let's go ahead and add that to both sides. I'm going to bring it up into this column. We will have 1,050x on the right. We have a 62,400 on the left. To that, we will add 3,067,050. Whew. Still dealing with some big numbers here. 3,129,450. And this is these huge numbers, the 3 million repeatedly. That's the reason why we generally scale back our years. If we divide this answer by 1550, the year is 2019. With those huge numbers, it's easy to lose track of what it is that we're doing. Let's go back and see. The U.S. per capita income can be modeled by this function where x is the year. Determine the year when the per capita income might be 62,400. I'm recording this in 2020. So last year, in 2019, the per capita income might have been 62,400. Feel free to look that up. Leave the answer in the comments if you looked it up. I'm curious. All right, so now let's move on to using graphs to solve problems. Use the graph of f to solve equations. Yeah, word doesn't like of f ever. If f of x is negative 4, remember this is the x-axis and this is the y-axis, and y is always a function of x. So I find negative 4 on the y-axis, and I want to know where does this hit the x-axis. I would say x is approximately negative 3/4. So I call it negative 0.075. Nope, negative 0.75. That decimal matters. Let's do f of x equals 0. So if my y value is 0, that's here. Y value of 0 hits the graph right here at x equals 2. Finally, if f of x is 3, if the y value is 3, that happens to be this top line right here. If I drop it down to find the x that goes with it, let's put some arrows here. This tells me that x equals 4. I like the idea of arrows, so I'm going to add them here as well. Negative 4, I go to the graph and find the x value that matches it. All right, so solving functions using graphs of the equations, we just want to report the x value that makes these happen. All right, so here's a little procedure. If you're having difficulty solving an equation, you could choose to use the x-intercept method. And what the x-intercept method uses is a graphing calculator. So let's go through just a couple of these. I'm going to go through one of them to show you how it would work. and then I'll do the other one to show you why it's sometimes necessary. So our first step is to get everything equal to 0. So first of all, I have 3x. Let's just add x minus 4 to both sides. It's already in parentheses. So there we go. And I could even leave it like this. I could simplify it. And we all are screaming, hey, Tuesday, x equals 1. We know that x equals 1. But the point is the x-intercept method. And so the first step is to get it equal to 0. Second step, and we could even go old school here, just type in exactly what my first step, how my first step was written. Now, if this is equal to 0, that will be on the y-axis. The y-axis, the x-intercept, can be found by calculating. It's in blue, so I'm going to choose that. I'm going to calculate the 0. What's it equal to? It's equal to 0. What's a number to the left of it? X value of 0 is to the left, so I hit enter. A value to the right of it, an x value of nearly 2 is definitely to the right. So we'll hit enter. I'm a bad guesser, I just hit enter. And here we find on the calculator that our x equals 1. All right, so the calculator, the x-intercept method does require the calculator. Now, why would I ever do that? It was far more work to do this on the calculator than it was to do it by hand. However, do you want to solve? Let's see if I can get my pen to work here. 4 square root of 2x minus the square root of 2 plus pi x equals 0. So that's 4 square root of 2x plus pi x equals the square root of 2. This is just solving. We'll factor out an x. And it is just horrible and ugly. So what we could do if we're going to find a round answer anyway, what we do on our x-intercept method is type in our y1 equals the left-hand side of this equation exactly as it's written. Let's see how quickly I could do this. Square root of 2 come out of the radical, parentheses 4x minus 1, plus pi is here the second function of our caret, the up arrow. If I graph this, somewhere close to 0, let's calculate the actual 0. You should hit the right button though. I'm going to go down to 0 before I hit enter. Left bound, right bound, bad guesser, and I have a nice decimal approximation. Let's call that approximately equal to. So the x-intercept method is helpful, so you don't have to put something horrible like this into your calculator to solve anyway. If you're going to use a calculator to solve it, x-intercept method's a great way to go. Alright, so we're almost finished with this video. It's getting a little longer than I wanted, but we're going to keep it kind of less than 30 minutes if I shut up and start talking again. I don't know how I can shut up and start talking. That's just my mood today, I guess. So let's talk about some application problems. In order to solve application problems, first of all, read the problem because you can't solve something you don't know what's going on. Make sure you understand it. Assign a variable to what you're being asked to find. If necessary, write other quantities in terms of this variable. Write an equation that relates to the quantities. You might need to sketch a diagram or refer to known formulas. Who knows, what types of problems we might need. Then we'll solve the equation, determine the solution, and always check to see if it's reasonable. Sometimes math solutions are good solutions, but in real-world applications, those math solutions have no real application. All right. So approximately 4.3% of all cancer cases diagnosed in 2016 were melanoma. If X cases of cancer were diagnosed, how many of these were melanoma? Well, we know that 4.3% is the same as 0.043. right? Percent is per 100. So we'd move the decimal 2 places. There's 2 zeros and 100. 2 places would put it here. So our number of cases of cancer, actually it's not cancer. This is melanoma that we're diagnosing here. Number of cases of melanoma in terms of the number of overall cancer cases will be 0.043 times x. We know there were a total of 73,000 cases of melanoma diagnosed in 2016. We want to find the total number of cancer cases in 2016. Again, that's a fancy way of saying solve for x. So 73,000 becomes our m value. The number of melanoma cancers were only 4.3% of overall cancers. Let's divide on both sides. And we will find that x equals, let's see, take my home screen here, 73,000 divided by 0.043. Wow, okay. Too many. It's too many cases of cancer. 1,697,674 cases. I'm going to round mathematically and say that 0.4 hasn't been diagnosed yet. That's a lot of cancer cases diagnosed in 2016. How much pure water? Pure water. So let's let x be the number of liters of pure water. All right, so pure water. Pure water has 0% sulfuric acid. So if I'm adding in pure water, 0% times the number of liters of pure water, plus a 40% times the 5 liters, I will get 15% of a total of x plus 5 liters of fluid. Now this looks a little weird. Why would I call it 0.0x? These are solutions. I want a solution. Water has to be written as a solution. Pure water has no sulfuric acid. So this 0.0 is exactly what you think it is. That does not contribute. So I want to find out how much I have to dilute this 40% solution in order to make a 15% solution. So I will have 2 equals 0.15x plus 0.75. We'll subtract 0.75 from both sides. 2, if I had $2 and I gave somebody 75 cents, I'd have $1.25 remaining. When I divide both sides by a 0.15, I got those in the wrong order, didn't I? Let me write that better. Divide by 0.15. Use our calculator over here, went to sleep on us. $1.25 divided by a 0.15. I would have to add 8 1/3 liters of pure water in order to dilute 5 liters of a 40% solution into 15% sulfuric acid solution. Now, how did I know to wear it around? Well, I realized this problem should have told me. If it didn't tell me 8 1/3, we know that it's 8 1/3, but please, no mixed numbers. No mixed numbers once you hit intermediate algebra. Mixed numbers are only for baking and carpentry. This is 25/3, but why would you tell somebody to do 25/3 of a liter? You tell them about 8 1/3, and you should be pretty close. All right, that's it. Thank you for listening.